This is the Amp Hour Podcast, released May 17th, 2020. Episode 493. PITA Package.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Who's coughing and spluttering, not because of something else, no.
Well, the coughing is probably because I can't get water out of my tap right now because there's a fire. There's an electrical fire near my building in downtown Chicago, and they shut everything off. The power's still on and the internet's on, so that's good.
Otherwise, yeah, this show could cut out, right? It could.
Yeah, maybe.
They could decide, oh, look, we have to fix this thing. We're going to have to shut the power off to all of Chicago or something.
Probably not all of Chicago, but no, yeah, it was like there's like a it's grids. They called it like a vault, like a power vault. I'm actually not sure what it is. Probably like you would guess it was like storage for something of like for the power company.
Well, I would guess it's some sort of underground substation thing. Some sort of maybe something like that.
Yeah, I mean there is like a substation right near it as well. There's an actual substation, but it's up the line a little bit. So because it's all near like the train lines and stuff.
Yeah.
But I guess they're diesel.
To produce that sort of smoke, I'd say it's like big copper enamel wiring from transformers or something like that. Because that stuff really, that stuff really smokes when you get it going.
Yep, exactly.
So yeah, something like that. So I don't think it's like equipment racks or anything like that. I think it's more probably copper's on fire.
Yeah,
copper and iron.
Whatever it is, it's underground and it's fire, and those two things do not mix in my mind. So I won't be going anywhere near it. Yeah. But I'm safe. Boy. So yeah, we're good to record at least. So that's
excellent.
Important.
All right, fire.
Yeah. Yeah.
Yep.
Speaking of things that are fire.
Yes.
As the kids say these days.
Where's this going?
I started making videos again, Dave.
Whoa! For your contextual electronics?
Yeah, I got a new course-ish kind of thing. It's like a follow-along.
New course-ish, right? Is this like a live thing again where people follow like daily, or are these a batch? You're doing them and then you're going to release them as a whole course?
No, this is a daily. Yeah, so it's like making one a day, one every weekday. So making a new board. It's going to be a more advanced kind of thing. It's Bluetooth, cellular, bunch of digital stuff, some power. So basically making like a development platform like I've talked about on the show before. I actually mentioned it last week on the consultant show, but decided to record some of it and put it up on the site. So yeah, we'll see how that goes. I'll probably put some stuff like outside of the the actual course at some point, but right now it's all background info. But because of that, I actually got a evaluation board from Quectel, which I found out is pronounced Quectel and not Quectel, Quectel. And it's pretty cool. It's a little EG91, which is like a cellular module. It can do Cat 1, so like 10 megabits per second and stuff like that. So yeah, trying that out, seeing how it goes.
Cellular, that's a weird sounded name. Is it company name, isn't it? Quectel.
Yeah, I'm sure it's something with Chinese characters that I don't understand.
Right.
So they're based out of Shanghai. They just went public last year.
Oh, okay. Right.
Yeah.
Okay. Well, the good thing about that is that you can get the domain name for it. It's not taken. So
that's right. Yeah.
Choosing one of these oddball names that doesn't really. Yeah.
What's crazy about it here? Actually, I can send you a photo. The dev board is interesting because it's a pretty standard dev board. They do a couple interesting things like for grounding. They obviously shield all the cellular components and stuff like that. So there's like a module that already has a shield built onto it. But then they actually put a shield underneath it as well, and then they have like this huge landing pad for connecting the ground of this plug-in module and the board ground, because you obviously want a really big ground for antennas and stuff like that, for like a reference plane.
Oh, but, I think I see it. It's like a huge copper pad, right?
Yeah, exactly. Yeah. And so that was one thing that was interesting about it. Another thing that's interesting here, I'll send you a link in the Zencaster chat, but another thing that's interesting is the fact, I'm not sure if it's interesting or what is this, but so they use DB9 for serial, which is not unusual, but like these days you'd think, it's just, then they just send a DB9 to USB cable with it. And it's like, is that cheaper than sending just another USB? Or maybe it's because they want to like make it very clear that it's a debug or a serial communication port.
Yeah, because a lot of people love their D9. They're familiar with it.
Really?
They've got their favorite tool.
Yeah, I
Of
guess so.
course,
Yeah, I guess so.
dude. What universe are you living in there?
But at the end of the day, you're plugging a USB cable into your computer. So like,
Yeah.
I guess you're saying because people want to use their own DB9 to serial to maybe to USB kind of thing,
Yes,
right?
they've already got their own favorite solution for debugging
Interesting.
serial. And it's like, and it might have been an old school designer as well, like a modern school designer, just whacked straight into USB. What do
Yeah, that's
you
what I would
want
do.
this
Yeah.
UART rubbish for?
Yeah.
And no, D9, yes, thumbs up.
I would put pins for the you could always hook into it, but like
No,
the fact that it's
no,
I was
no.
wondering
Old
if it was
school
also
D9.
because maybe it was like cheaper, maybe like there's enough infrastructure that was cheaper, but it sounds like it's actually maybe not cheaper, it's just more of a preference kind of thing.
It's more of a preference thing, yeah. I like obviously a D9 is not cheaper than a pin header, of course.
Yeah.
Or
Well,
just,
that's
hey,
true, yeah, right.
like
Yeah.
a 5-way pin header or whatever. But it's
Mhm.
it's the universal standard. It always has been since before you were born.
I'm sure it
So
was, but I don't usually see it
yeah.
on I don't see it on dev boards normally. That's what I'm really
No.
getting at, I guess.
Always in your lab, always have an old PC with a D9 serial connector on it. Very
I
handy.
guess so. Yeah.
Yep.
That's the reason. That's the whole reason you do dumpster diving, huh, Dave?
Right. Yeah. I love. I pull out an old one, especially like a combo mod that's got like modern USB 3 in it, but it still has a D9 on the back because they're still used in the PC world for like a server interface, debugging connection.
Oh, really? Interesting.
Please correct me if I'm wrong, but I still believe there are server, modern server, brand new server computers that'll have a D9 on them.
Interesting.
Yeah.
Yeah, I've seen pins. So like, not all of the cases have a D9 or DB9 connector on the back, right? So sometimes they'll have pins so you could hook it in, but it's just doing the same thing, right?
Yeah, exactly. But usually, if a D9 implies that it's actually an RS-232 interface, so you've got to have the UI, you've got to have the RS-232 level converter chip in there. So you've got to have like a Max 232 or some sort of equivalent chip in there to do it. So it's definitely more cost. I mean, you could use the D9 as like a TTL output, but then that defeats the whole purpose. You might as well just have a pin header. Because when you see a D9, it implies, RS-232 signal levels. This is not TTL.
Right.
This is RS-232. So, yeah.
That's a good point. Yep.
Very different signaling levels. Yeah.
Yeah. Right. And I guess it's not. I don't know if this is an isolated one either, because those come in isolated, right? Like they get isolated. Some of the 232s.
You can get isolated versions. Well, yeah, you've got a. Well, do they have isolated directly on chip?
I'm looking at the converter chip now that you point that out, and it is pretty wide body, but I don't know if it's wide enough to be.
I don't think it's isolated. It's probably just a Max 232 or equivalent. It should have 232 in the part number somewhere. Yeah. I would be guessing.
My old eyes, Dave. They're not.
Yep, they're not. Right, yeah, they don't. Yeah, join the club.
Gotta get the old cell phone light out here.
Yep, the old Mark 1 eyeball just doesn't do it anymore, huh?
That's right.
Yep.
That's right.
Yep. I've got a Mark 2 eyeball. I got my glasses now. Yeah? So yep.
You have glasses? Is this new? No, you've had glasses.
I've had glasses for years now.
Okay.
I use it in most of my videos now.
Oh yeah, I guess when you're like streaming and stuff like that, right?
Yeah. Oh yeah. Or if I'm doing a video talking head screen capture thing, I'm usually using my glasses to read them on. I don't need them, but my optometrist says I wear them. Wear them. So yeah, I wear them for looking at monitors now and everything else. Yeah. So yes, it'll be less strain. Otherwise, my eyes strain too much, and that'll just make them worse, and they'll deteriorate quicker or whatever. I don't know. So
time marches on, Dave. Time marches on.
Exactly.
And the cat's in the cradle with the silver spoon. Oh boy.
Yep. Sad. All right. What do we got for today's show?
You did a stream, or not a stream. You did a talking head video, and you've been playing with the Padauk 3-cent micro controller.
Yes, I'm back to the Padauk 3-cent micro. And
cool.
remind me of a segue. We can probably do a chip of the week segue with that.
Okay, well. Cool. Yeah, so that first video was you making the actual programmer, right? Or looking at all the parts, you'd already made it.
I've had these parts forever and I've been meaning to assemble it. And I thought I was originally going to do like a live stream of just me assembling the board, like a live
Oh, those are tough.
thing,
Yeah.
just assembling the board, and then just do one video of like,
Uh-huh.
oh, here's using this new thing.
Ta-da!
And then I thought, no, I thought maybe there's need for a sort of like a multi-part tutorial out there of how to take any GitHub project, really, any GitHub hardware project. So if you go, oh, I want that widget, but nobody sells it, right? Nobody sells the kit, nobody sells a made up one or whatever, and I need that little widget. How do you go into the GitHub, take the PCB and schematic and the BOM and everything, and actually get it manufactured and then tested and install all the drivers? And it's, yeah. And of course, it turned out I was right. So I thought, oh, maybe this will make a multi-part tutorial because things will go wrong, and you learn when things go wrong. You know, oh, look, I installed this driver and it didn't work. Okay, why?
Right.
Let's troubleshoot it. And there were lots of stuff like that. So yeah, so it turned into a 5-part video series of like each one's like half an hour or something like that. So, you know, but that's the amount of effort that is required to get something like this, you know, built and up and running. If you aren't familiar with it. So it's basically you sitting beside me actually doing this thing, you know, actually getting it all up and working. So
where did you get this idea from? Some kind of like project-based education, Dave. It's so innovative.
So innovative. Oh boy. I've been doing it for years.
I think there's it's a different experience, right? Of like, it's a slower kind of thing. People have to be patient through it, and you don't get as much of like you don't get much of the summary.
No, and I expect the views to be low. It's not like a Great Scott. It's not like a 5 or 7 minute Great Scott video of here's how to use your Padauk microcontroller in 5 minutes. You know, where everything goes right and everything's, you know, everything's perfect and polished. And this is for those who want to see the entire process, warts and all, kind of thing. So
there's one thing Dave has: it's warts.
Exactly. Oh, it's not quite. It's edited, so it's not like, you know, if it was live, it'd be, you know, there'd be a lot of, you know, it's a bit better than doing it live. Yeah, there'd be a lot more warts. But anyway, in the spoiler alert, turn off now. Mute your podcast now if you don't want to hear what happens in the final video. Do you want to know, Chris?
I'm muting. No, I don't know. Yeah, go ahead.
Is that
did it all work out in the end, Dave? And we all learned something today?
Well, the chip worked. Like, you can see it. The first thing in the video is that, like I powered it. You know, I've spent the last 4 videos building this thing up, programming my chip, and I finally get it to program. And then I go to put it on my breadboard, and it's a UART, right? It's supposed to spit out "Hello World" from a software UART. You know, an IO because it doesn't have a hardware UART in it for 3 cents,
just
right?
Bit toggling,
bang, and and I get data on the screen. You know, I get data on my scope, and yay, winner, chicken dinner, right? And then I start looking at it, and I'm going, that's not a UART signal. That's like a clock thing. And then when I went to go in and touch it, the signal started to change as my hand got closer to it. And so this data packet is actually changing length as my hand gets closer to it. It's like spooky action at a distance.
Huh.
This is Einstein stuff, right?
This is nice. And I mean, there's electromagnetics involved, I suppose, but that's about as much as we're going to give you.
No, it's capacitance, sonny boy. It's capacitance. Right. And so obviously it's what's happening because it's a UART-driven program. It's an interrupt-driven program, right? So I think what's happening is the chip was obviously programmed incorrectly somehow. And it was, I still don't know. I still haven't solved it.
Someone did this. So who did this? Come on.
And one of the inputs, because all the inputs were floating, right? Because this was just supposed to have a single output. So none of the pins are tied anywhere, right? So obviously I believe it, because if you see anything change when you move your hand towards it, then you can be pretty certain that you've got a floating input somewhere, right? That's actually capacitively coupling like 50 hertz that's picked up from your body and stuff like that, right? So so it was interrupting. It was probably restart interrupting this damn thing all the time, and it was it was spitting out this random clock thing as my hand got closer. It was really bizarre. Anyway, you have to watch the video. I still haven't solved it.
Oh,
Unfortunately.
I thought there actually was a resolution
Oh,
to this.
well,
You're saying?
no, there is a happy ending because I tried another example program that did work, right? So apparently
Got
this
it. Got it.
program was not written for the actual chip I had.
Mm.
So there's obviously some sort of subtle variation in there. Something's wrong. So you have to really. I tried to rewrite it. I tried to like go into the instructions, like and actually almost rewrite the entire thing, but it still didn't work properly. So yeah, I
Mm.
don't know. I'm sure some people solve it and get it working. But anyway, yes, I was able to blink a lead, like
Okay, that's a good
yep.
start. I mean, like, what are you hoping to use this for in general? Like, or I guess more broadly, like,
Absolutely nothing. It's just for interest sake. Although I thought maybe, oh look, wouldn't it be cool to have like get this gigantic panel with like 10,000 microcontrollers, like the world's biggest distributed computing cluster or something. It's got like 10,000 micros on one big
right,
panel. It cost you more to program the pick and place machine to do it than it would for the actual micros and the board.
right. And
So
what is the programming mechanism for it though? Is it like are there like program pins on it, or can it load over? Is there a bootloader for UART, or how does that work?
Oh, it's like a PIC kind of system. It's like a higher voltage thing. So
Uh
that's
huh.
why the
Okay.
programmer board needs like a higher, like a 12-volt voltage, DC to DC boost converter. So you've got to like hit it with like I think it's 6 volts and 12 volts. So you've got to like put it up to 6 volts, and then that pulls out the ID from the chip or something. Anyway, somebody's reverse engineered. They had to reverse engineer this
Got it. Got it.
to be because I actually asked Purdue if they would release the programming information for it, and they said no, sorry, it's proprietary. So everyone on the
Right.
EV blog forum went, well, screw that. We're going to reverse engineer this thing. Now they've completely reverse engineered it. It's even emulated. You can actually get
Yeah, I saw that. Yeah.
the Purdue microarchitecture and whack it in an FPGA. Fantastic.
I would love to know as these things are being designed into things too. That I mean, like, I guess that's what I'm really wondering about is like the application level of like what people are using super tiny micros for in general, just because
Mm,
they're super cheap, super tiny. I
yep.
generally I'm interested in that of like is it just one-off functions or are they trying to squeeze more stuff into it? I mean,
Well, there'll be those who are doing it for the fun, right? Yeah, for those
sure,
who
sure,
there'll be those doing it for the fun, and a lot of comments on the video were like, "Well, what's the point of this? This is useless for a hobbyist." Yes, of course it is.
yeah,
If you're building a one off or 10 of or even 100 of units, right? It doesn't matter whether or not you pay 3 cents for a micro or 30 cents or even $3 for a micro, right? It doesn't
right,
really,
yep, yep,
especially for a one-off. It doesn't matter, right? So you may
yeah.
as well use your more refined, your picks and your AVRs and whatnot, right? Your STM32s or whatever.
I mean, if you have the money for it, right? I mean, I guess it always comes down to like if you have the dollars for it, you could just throw an STM32 on it or whatever, or really
Yeah, but
whatever
even
your platform is.
STM32s are 50 cents or a dollar,
Yeah, no, exactly, exactly. I'm just saying that.
So
Yeah,
it's
it's
like,
like it has
it's
to be something high
it
volume
makes no
enough and
difference. Yeah, it's
probably
got to be something
compact
high
enough of a
volume enough. Yep.
yeah.
Yeah, you've got to be using like multiple ones on your design or something, squeezing
Right,
every
right,
cent out of your design. So, yeah, but it's just
right.
interesting. A lot of people are interested in this thing, just from the
Sure, sure.
just
I think
purely because it's a challenge and it is 3 cents. It's crazy.
yeah. Yeah, I
So,
think that
yeah,
that kind of gets people's imagination kind of running wild of like, oh, I could do anything with this, and then it's
yeah, yeah,
the
exactly.
reality is, of course, something less, and when you really are going to spend that kind of time on it, it's like, yeah, maybe you aren't going to use it for everything, but I think it does. It's a great mental exercise, and for some people, they actually will use it for products or whatever's out there. So
Yeah, they
I would
certainly
love to hear
could.
about it if people have a list or something like that. I would love to see a list of what it goes into eventually.
Yep. Oh, segue. I almost forgot.
Yeah.
3 cent microcontroller. Spoiler alert, I'm probably going to do a video on this to actually test it out, see if it's any good. What about a 1 cent voltage regulator? There's a jelly bean part that everyone's going to use, right?
Adjustable or fixed?
This one is fixed. You can or get it in like, different voltage grades. So 5 volts, 3.3,
Okay, sure,
1.8,
sure.
etc. But
Yeah,
they're 1 cent, right?
yeah.
So
Okay.
everyone uses a voltage regulator in almost every design. It's almost universal, right?
Yeah, well, that's kind of a broad statement, though. I mean, like,
Oh, but come on, right?
But they're different. Well, it's different based on like what the needs of the circuit are, though. You know what I mean? Like it's
Yeah,
not
of
like
course. I know you might need a low noise voltage, but most of the time,
there is no universal.
yeah, but most of oh no, there is. Come on, come on, a standard 1117,
Okay, so what's the 1 cent one? Like how much current output can we get out of this?
300 milliamps.
Okay, yeah, then that's fine, right? I mean, I just mean that like when you have starting to have higher current needs.
Oh, well, okay. If you have higher current, you're going to need a higher current regulator. But most people are going to be running like a 3.3 volt microcontroller, and they're powering it from USB or they're doing whatever. And so they just need a Jelly Bean 3.3 volt
Yeah,
voltage
I agree with that.
regulator, right?
Yep.
Yeah.
Agree.
And you can get them for 1 cent.
Okay.
Which is absolutely amazing from different companies. There's multiple companies, but the generic part number that I've got is the 6206. The one I've actually got in front of me is the SSP 6206, but I'm looking, there's actually cheaper ones on LCSC.
I was gonna say, is this just you browsing through, like sorting by cheapest to most expensive?
I'm sorting by cheapest. Yeah, I'm sorting by cheapest. So the cheapest one looks to be the XC6202.
Yeah, I guess the power, the linear regulator thing doesn't really inspire much creativity in my mind, at least. Maybe it's out there, but like it feels like the programmability makes it something special for the 3 cent microcontroller. You know what I mean?
Right. Yeah. No. Of course. But because most people aren't going to be using a 3 cent microcontroller, right? But everyone is going to be. Every man, like eventually, you're going to use a voltage regulator, right?
That's right. Yes, that is correct. Yes.
Right. And why would you pay 30 cents for one?
Right. Would you pay 30 cents for this chip? Oh, I would. Would you pay 10 cents for this chip? Oh, yeah, I would. Would you be willing to pay only 1 cent for this chip? Yeah, I'd love that. Anyways, go ahead, sorry.
And the first 50 callers get a free set.
Exactly. Yep, exactly.
Oh boy. Anyway, what out of curiosity, I'm just searching DigiKey right now. What is the cheapest LDO you can get? What's the cheapest regulator you can get? Let's have a look. Unit price.
What?
Let's go.
While you're doing that, I want to bring up as well that there is a new. I'm trying to find it while we're doing this too. I should have had it up before, but there's a new FPGA maker on the scene as well that has like a $2
another one?
FPGA, a single quantity $2 FPGA, which is kind of crazy.
Yeah, but tell us the package, son.
That's what I need to. That's where the trick comes in, Dave. Yeah. Welcome to Dave and Chris Google.
While you're looking for that, the cheapest name brand voltage regulator looks to be 5 cents around, or 4 cents, but that's in a TO92 package. So let's not go there. It's a mic, and so there's a microchip one, which is actually an old Micrel one. But then there's an on-semi one, 5 cents, 5.6 cents. So the ones I'm talking about are 5 times cheaper. And these are 1,000 of quantities too. And they're a little pain in the ass package. Look at it. I'll show you this. Oh man, this is some evil shit. Look, let me. Just no. I don't even know what package that is.
4 dots, the 4 dots of salt. Oh yeah, those are nice.
Yep.
I've seen
with a power pad on the bottom. With the power pad on the bottom. Yeah. What do they even call that package?
To give an audio picture, it's like a diamond in the middle, which is like it's like in a diamond shape because it's not square with the pad. It's like a square package, but it's a
4-pin XDFN. So it's an XDFN exposed pad. So what the pad in the middle does nothing? Is it not connected?
You got to heat sink it.
No, but it says it's a 4-pin. It doesn't say it's a 5-pin. So there's 4 on the outside. And there's no. This is wrong.
Well, I'm trying to find the dimensions of this thing too now.
No, the pad in the middle is not. It looks like it's not connected. Although it's available in the SOT23.5. This, by the way, is the NCP 115 for those playing along at home, and it's available in the SOT23.5. All this weird ass XDFN package, which is the cheaper one. So you can't get the SOT23.5 for that price. Yeah. You have to get this pain in the ass.
1 millimeter by 1 millimeter. That's the total
is it?
package size. Yeah.
Oh
Yeah.
no, no, no,
So
no.
the pins that are actually the actual conductive pins are like these weird corner pads, and it looks like
Yeah.
they're point 0.24 by point. Oh, it gives a different size pad size, but 0.24 by 2.26.
Ugh.
Yeah, those are fun. But you know what? It doesn't take up much space, so that's
No, no,
nice.
and that's the whole point, and that's why it's cheap because they're used in mobile phones and
Yeah.
whatnot. You know.
Yeah, that came up again. There's a video we posted to the subreddit this week. He does the flip displays. There we go. Carl Bugeja. Carl, he did a bunch of PCB based motor driver or motors as well. So he did this for Hackaday Prize, and he has a bunch of cool videos about PCB motors basically. So he puts the coils into
Right.
the PCB, and then he drives motion with by driving current through them and stuff like that. So he has a product where he was doing the same kind of thing, where he's got a PCB, he's got a flex PCB with a coil in it, and he drives current through it with motor drivers. But he found a new chip for it instead of using an actual H bridge, which was like one of the TI DRV parts. He switched to
Yep.
a haptic driver, like the phone buzzer thingies, basically. The thing that drives your
Right.
buzzer on your phone.
Yep. I'm
But
watching
it's
the
just like
video now. So
anything like
yeah.
that. Yeah, anything like that where you can harvest something off a phone. You're gonna be super tiny, but you're gonna get super cheap stuff out of it. So that's kind of nice.
Right.
And so he kind of goes through how the differences between an H bridge and this specific driver part, and he tested and stuff. It's a cool video. I liked it.
Anyway, I hereby deem that the XDFN4 package wins the pain in the ass package of the week. That should be a new segment. Seriously, 1 millimeter by 1 millimeter with it. Oh, bloody no.
Yeah.
Wrong.
I've been getting more comfortable. So I've been doing a lot of, I think I have an 8-pin, I have a 6-pin BGA on a recent board. I have an 8-pin Xson, something like that. Or is that what this was? I don't know what the part names are, but much tinier than I've been used to. But did I tell you about my new microscope setup? I tweeted about that this week.
You tweeted about it. I saw the photo. It's a big, long,
Okay. Yeah.
zoom lensy.
Yeah, so it's got it's like a telescopic lens,
thing.
and then it's got like a
Yep.
440 megapixel sensor on it, and then I just hooked it up to an HDMI meter or HDMI screen, kind of in line with what I'm doing. People pointed out rightfully so. It's not a microscope. It's not it's obviously not stereoscopic, so I don't get depth perception. But for me, it's just been super helpful just to get to the detail levels that I need to, and I like that it's like out of my workspace. So it's as it's shown, it's mounted out of my.
Oh yeah, the working distance is like 400 millimeters or something, right? It's huge.
Exactly. Yeah, it's really nice for that stuff, and it's a video by Voltlog. So he had recommended it actually as a add-on to like a low cost. It's like a trinocular microscope.
Yeah,
and
stereo
then
microscope.
But then at the end he's like, yeah, you can, stereo microscope with like the port for doing HDMI capture too, and at the end he's like, yeah, you can just buy it by yourself, and it's like $95, I think, shipped. So like, that was awesome. So yeah, new
I was doing that. Like, I love my Tagano microscope for like zooming in and stuff. It's got a huge working distance, zooming in. It's got 30 times optical zoom. It's it's absolutely phenomenal. Nice. But I hate soldering under it with a HDMI monitor. Yeah, no, it just because you don't get the depth perception and stuff like that. But it's the best thing I have for video capture. Right? I can't use.
What would you prefer for soldering?
I would use my Mantis, which is a stereoscopic hood based microscope.
Sorry, I was getting those confused. Getting those confused. The Mantis is one like the heads-up display. You're saying,
and the Mantis is the heads-up one. Yeah, heads-up analog.
Got it.
Real lenses and mirrors and shit. So and that one does have a camera built in, but it's so crap.
Yeah.
It is like it can't even take a decent photo, let alone video. It's just, and the optical quality of the Mantis, if you've ever looked through one, is phenomenal. That's why they're super expensive, So I've got this phenomenal optical microscope, and I can't get with the factory built-in camera, and I don't even know why they even sell it with the camera built-in. It is, it's absolutely useless. So I do have other stereo microscopes here, and I do actually have technically a lens capture attachment for it. So maybe I should look at, but it doesn't have a big working distance, it doesn't have a big, optical working distance. So if I want, a large optical working distance, well, the Mantis isn't that huge a working distance, but it's good enough. So, yeah. But it only I do have a ×10 lens for it, but that's too much, and then it gets too close and stuff like that. So I
Yeah,
usually only
exactly.
solder with a ×4 or a ×8 if I need to zoom in. And my normal zoom level would be 4.
Yep. I think the thing with the for me at least, it's like being able to get hot air under there too is like important. Like soldering, yeah, of course you need that, but being able to get like the hot air pencil under there and like not damage anything, that's another thing that's like super critical
Oh
for
yeah.
me to be able to just to manipulate things and move them around. Because I keep stupidly
Yep.
designing in tiny switch mode supplies and all these crazy ass packages they keep coming out with. I'm like, ooh, new part. I'll try this. Bad idea. Bad idea.
Yeah.
Yeah.
What's the world coming to? The world's going to shit. I'm telling you. Mars.
Oh,
Yep.
that's what made you notice. That's what made you notice, Dave. Was the microscopes? It wasn't anything else.
Boy. Anyway.
2020.
Yeah.
Was,
Pain in the ass package of the week. Yeah.
Okay. I can't find this FPGA thing. It was somewhere on the consulting forum. I can't find it for the life of me. So I don't know what the hell it is. Yeah, it's some new. There's the new FPGA out there. I'll try and find it for next time. We'll see how it goes. Right.
Speaking of soldering, another segue.
Yeah,
I did a recent video on a soldering fume extractor. What sort of stuff what fume extractor are you using at the moment, or nothing?
Yeah, my lungs, unfortunately.
Sucking it up like a man, yeah. Right.
Yeah.
Put air in your chest. Yeah, right. Yeah, okay.
Yeah, right. No, it's stupid. It's I don't use I had one of those, just the cheapo, molded black plastic with a fan in the back and like a carbon filter. But you have one that looks like a elephant trunk almost, right?
Yes, it's a big snaky thing, so it sits under your desk, and I got this new big snake, the big snaky nozzle thing comes up over the bench, and you put it straight over your work, and it works well. But the problem is, I think it's even like I got the low noise model. It's still not low noise enough, So
that's always the problem.
It's frustrating.
I have been noticing as I do a lot of video calls. Everyone's doing video calls these days, but my hot air pencil is left on. Oh, that's loud. My VNA's on. That's loud. Everything's got a fan. Everything generates heat. It's like, yeah. So, noisy stuff. What are you gonna do?
Yep. I don't know.
Invent.
So I'm still looking for the
quiet
perfect
fan.
Well, I do have, I modified one of my Pace ones to put a quiet fan in. I had this 240 volt, mains fan in it, and it was sounded like a sound like a jet fighter starting up.
Yeah.
And so I modified it with a really silent PC fan, and it's great. It's really silent, but it doesn't suck much. So I want my
it sucks.
I
want
my
suck.
fume extractors to suck. Yeah. And so you have to get it really close. You've got to get it right up in there to sort of, you got to be right next to the damn thing. And most board, which is okay if you're working on a tiny little board, maybe, but if you're working on anything larger, it's just hopeless. It just because your board is too far, and so the fume extractor's got to be on the other side of your board. So anyway, yep. So you need these snaky arm ones are great.
A big fan to just blow it across the entire desk, and then have some
that's
the
other thing you can do. I've actually done a video on that too. Yeah. You can just modify it. Just get a regular PC fan and stick a battery on it, or with a boost converter, and bingo, you've got a little fan to just blow it out of your face at least. Which is a fine solution if you've got open windows and open doors and stuff like that. But if you're in
or if you're doing air filtering other ways in your
if you're doing other exactly. I could use my other big air filter in my little soldering room. But anyway, fumes. When I was a boy, yep.
I mean,
suck them right up.
I'm trying to, I've switched to lead free, but the flux is still not great. So, and that's usually what's kicking off a
You
lot of the
do
fumes
realize
anyways.
there's
So
no lead fumes in it. You do realize lead fumes aren't a thing, right?
right, exactly. Yeah.
It's the same rosin flux that you're sucking up, regardless of whether you use lead or lead free. So
Right, exactly.
makes absolutely no difference. Yeah.
Yep.
Anyway. Mm.
Did we mention on the show? So I had mentioned on the show about Alvaro at one point making a storage system. Did I mention
Yeah,
that?
storage system. Yes, you did. Yeah, you mentioned it the other week,
I
and
did.
I've
Okay,
watched
I
the
wasn't sure when that
video, and
video
it's
came out.
like, yeah,
Yeah.
it's a lot of effort, individually bagging things up, making printing barcode labels for them, and putting them into a database. And there's some reasons, some people would get great advantage from doing this, but most people wouldn't.
Yeah, I
So,
think it depends on the type of work you're doing for sure. If you're doing
yeah,
like for me, I've been doing project based work, right? Just for different clients. And it's as long as I have the parts for the build, it's like I put all the parts in a box and they stay there and I label the box
yep.
and that's fine. It becomes a storage nightmare, of course. And then the
Oh, it
problem is
does.
like
No,
when the
it is.
project's, moves on to the next rev or whatever, then it's like, okay, now what do I do with all these parts? So that's when I think this kind of thing comes in, because then I'm like rooting through the box when it's not
Yeah.
when like the next rev needs a part and I'm out of it or whatever. But
Yeah. But sometimes
yeah,
it's often just easier, cheaper, and saves time just to simply, regardless of whether or not you've got the parts, just order your entire bomb from your DigiKey or your Mouser or your
yeah,
LCSC or
yeah,
whoever you happen to use. And it all just comes and they're all bagged and they're all
yep,
labeled and they're all ready to go. And yeah, you know, it's just,
yep.
it's just easier. Yeah, it's kind of, it's wasteful and it's, you know, stuff like that. But it's like you just can't. Like, there's always going to be parts that you can't use. So what are you going to do? Like, sure, you can check your database if you've got this system. Oh, I know I have X number of those parts, so then you don't have to do it or whatever. But as I showed in my recent video, my first in this multi-part series video of how to upload a bomb to your DigiKeys and your mouse as your component supplies,
Yeah,
you can
right.
just upload your
Yeah.
XL bomb, right? And bingo, you can, it takes like a few minutes. It'll take longer to search your database and figure out manually what parts you have and then actually remove them from your bomb, because you're almost going to have to, almost certainly going to have to order something from your component supplier, right? You won't have everything.
Well, and I think that's the thing is like if you have enough iteration, then you might, right? But yeah, I think that's the
You
point when
might,
this kind of
if
thing
you're
makes
doing
sense.
subtle variations on the same project every time for 10 different
Right,
clients,
right,
then
exactly. Yep.
yeah, of course.
Yep.
But as I said, very few people are going to be in that position though. It's just
Right.
like
Yep.
having your own pick and place machine. It's going to be useless for all but a very select few people who have that particular requirement.
Yeah, and almost. Yeah, I wonder if that crosses over too, because then you'd have like it'd be beneficial to have the same parts again and again and again, and it would change your design mindset too, right? We wouldn't be looking at any 1 millimeter by 1 millimeter,
No.
like cheapest parts. It's the cheaper
Yep.
thing in that case, especially if it's low volume, is just to use what you got. So
Yeah, of course.
that's the reason to do that kind of thing.
Yep.
Yeah.
And then the size and shape and everything of your board is actually dictated by the parts you've got. So
exactly.
Yep. Unless you're designing like a new smartwatch or something, no, you're not going to be, using this pain in the ass 1 millimeter by 1 millimeter package.
Yeah.
So
yeah.
Ah, boy. Anyway.
Yep.
What else we got?
Oh, not much on the list. I almost electrocuted myself the other day. That was fun.
Excellent. Well done.
Yeah.
But you've just got that wimpy 110 volt rubbish in the US.
This was a isolated transformer that can do a kilowatt. So it was
kilowatt,
more.
Yeah. It has but it's still only 110 volt, right?
I mean, no, it was a DC bus voltage that was generated and stuff like that. Anyways, it was bad. It was floating
Right.
much more above chassis than I thought it was, and
right.
And I went to go measure with the scope, and scope grounds or chassis
scope
a scope.
It said, I swear, on this audio link, it sounded like a skoke. That's like a scope that's gone up in smoke. Is a scope.
That's actually about right, actually. Yeah, yeah, no, and so the things are chassis grounded, and and kabam! I vaporized a wire, so that was fun.
Nice. Yep.
Yeah, it was my little bit of welding for the day, I guess, and scattered some carbon all over the place. It was actually kind of interesting. So one of the forum members, he actually reviewed a super low cost handheld scope. I wasn't really expecting much out of it, and I mean it's not that great. It's like low cost displays and stuff like that. But for that kind of thing of where it's a floating scope, then right, you're not tied to chassis. You don't need an isolation transformer or anything like that on your scope. Then you can do stuff like that. So I don't know. I thought it was pretty cool. I'll send you a link.
Oh yeah, no, that's why I have a portable scope. It just it's nice.
Yeah, exactly. Yeah. Right, when you're doing like high voltage stuff and things are spread out.
But I've got high voltage probes as well. I've got high voltage differential probes, which aren't isolated. By the way, I've done a whole video teardown and actually reverse engineering of a high voltage probe video.
Oh yeah.
And people just assume that these high voltage probes are isolated. They aren't. They just use a crap ton of resistance in series, so that the current, that it's they just use
little
these
bits
high
of current
voltage
at a time.
strings, and they basically a 4 meg resistor in each line, and then you have a resistor voltage divider, and that's how it does it. And it doesn't blow stuff up because it's 8 meg.
That's right. Right.
Yeah, there's not much current you can do unless it arcs over. But that's why they put multiple resistors in series on the string, because you can't get a 1 kilovolt resistor. Well, you can, but they're special, right? So you just get you just put 4 or 5 1206 resistors, which are about 200 volts a pop. You put 4 or 5 of those in series, and bingo, you got yourself a do-it-yourself high voltage resistor, and that's how they do it. So
that's the way to get it done.
These high voltage probes, they're not isolated, so. And they don't have to be, so which is great.
That's awesome.
Yep.
Yeah. So for $100, interesting. I'm not sure if I'll get one, but the it's a cool review of a low cost handheld, because usually the handheld ones are I don't know how much yours was, but the ones I've seen are pretty
mine was
pricey,
like $50 or something.
Oh really?
I've got a high end one, but I've also done video reviews of cheap ones. So I've got like one of them's like $50 or something.
Got it. Yeah.
Super cheap, and it's got like 20 meg bandwidth. It's
right.
Which is good enough, but it kind of it's they're really built down on price. So
right, exactly.
For a reason. Yep.
So how goes the speaking of test equipment? How goes the micro supply?
I will get back onto it. I'm going to do a summary video of like state of the nation, where it's at.
Okay. Yeah.
People will see it.
Okay.
So
that's good.
Yep. I just it's just me at the moment. So
that's right. That's right. Back to Back to just Dave.
Yep. I've got lots of and I've got other products which I've got to evaluate as well. I've got an issue with my microcurrent that I've got to solve, because that's not for sale at the moment. A lot of people keep asking. There's an issue there that needs to be solved, and I've got a couple of new products that I need to evaluate for sale. Things like that. So, yep.
Great.
Because I've got to stay in business. I've got to flog stuff. For a living. Yeah. This YouTube gig still doesn't really pay the bills, so
that's right.
After a decade,
right.
Got to flog stuff.
Yeah.
No, well. Yeah. So that sucks up a lot of my time.
Yeah.
Speaking of.
Sorry. Going back to soldering, rather. I've been doing a bunch of tiny mods because of tiny mistakes, and
have you been swapping pins and stuff like that?
Yeah. Well, more like forgot to assign pins or got the wrong pins on a QFN part, and so I've been doing enamel wire jumpers and all that kind of fun stuff. But it's I've been using my share of flux, and I was asking over on the consulting forum, and I thought maybe I'd ask here too, of like, what are you usually doing for like cleaning up boards? Like, are you you just going straight with isopropyl, or what are you doing these days? If you're, I mean, do you ever use ultrasonic or anything like that?
No, I don't use ultrasonic. I've got various flux removers.
Yeah.
Like I've got a
Any
local
prefers?
Chemtronics Australian brand flux remover. I've got heavy duty flux remover, and
Uh huh.
which isn't just IPA. It's not IPA. It's got
No,
other,
yeah, yeah. It's got other things that'll kill you.
tetrachlorohydrazine
It's
or
yeah,
something in it.
yeah, exactly. There's always like some kind of benzene ring in there
Yeah,
that's
I
going
don't
to
know.
make you
Yep.
asphyxiate. Yeah.
I can actually go and get it, and I can read you the. I
I mean, that might
read you
be
what's in it.
interesting. Yeah, yeah. Yeah, so this bodge
Hang
that
on, hang on. I'll be back.
okay, I'll
You
talk
can
about the
entertain the
bodge.
audience.
Yeah, okay, yeah, we'll see how that goes. Yeah, so this bodge was a bunch of enamel wire, which I had never done before. I will put a link in. I had an enamel wire, 30 wire, 30 gauge, 30 AWG, but I had never I never actually used it before. I was looking at like how to strip it, and there's a article on Hackaday about just burning off the ends, which people were using enamel wire, like, yeah, duh, no joke. But yeah, it's pretty easy. You just basically put some solder on the end of your soldering iron, and you put the wire to it, and just burns the enamel right off. So
Yep.
a new way to solder stuff on there. Yeah,
Don't breathe
I
that
had not used a
stuff.
lot of magnet wire in the past, so yeah.
Anyway, Ultra Flux Remover. Unfortunately, it's non-corrosive, low toxicity. It's a ChemTools Cleanium Ultra Flux Remover, but it doesn't actually tell you the ingredients. So I guess you'd have to read the MSDS for it, the Material Safety Data Sheet.
Oh,
I guess, yeah, it doesn't
yeah.
actually doesn't tell you what's in it, but yeah, it's not just
Not pretty.
isopropyl. So
Yeah, right.
yeah. Anyway,
Okay. Yeah, because I know
cool.
I have what's it called? Not shellac, but the conformal coating stuff, and that's another one where it's like you look at a conformal coating spray container, and it's nasty. It's real nasty.
Yeah. Oh yeah, that's horrible stuff. You need like a fume hood, or you need to simply put it outside somewhere while that
Yeah,
stuff's
exactly.
yeah.
Yeah, don't want to concentrate that anymore.
No.
Okay, so you're just using flux remover and isopropyl.
I just use flux remover, and then I might use an isopropyl thing, to clean it all up. But generally, yeah, heavy duty flux removers are good.
Mm.
Oh, ingredients. Here we go. I've got the ingredients.
Okay.
Hang on. Light hydro treated petroleum naphtha. Propylene glycol.
Closely related to napalm.
Yeah, love the smell of napalm in the morning. Propylene glycol monomethyl ether and isopropanol.
Oh, okay.
Yes, anol, isopropanol, not isopropyl. It's got the AN in there. So, yeah, so it's got a combination of all these, oddball.
I mean, Mrs. Evie blog's a chemist, right? She could tell you what some of those things are, right?
Yeah, I'm sure she could. Yeah.
Yeah.
Oh boy. Yeah, not good. So anyway, that's why I've also got my fume extractor is not just a fume extractor; it's got a charcoal filter as well, which takes out the the toxic fumes as well. So yep, does both. Anyway, yeah, heavy duty. I've got ultra and heavy duty. Oh yeah.
People were saying so one of the reasons that I was asking about it too is because one of the boards that I'm doing has it's a humidity sensor, and so I figured that's got like water ingress. It's like tiny the hole on it, but just thinking about like washing. I still get kind of antsy about just like washing boards. Like people there's like water soluble even flux and solder and stuff like that, but I still am just. Like water and circuit boards, you're not supposed to do that, but it's like,
I know. I know.
You really can't do that
requires
stuff.
a leap of faith. Yeah.
And then then you could dry it off and heat it up and whatever. But
I'm not going to be using if I've got the isopropyl, I just use the isopropyl.
Yeah.
It's like and a brush. It's nice to have a nice conductive. You can get one of the conductive brushes, right? The proper PCB scrubbing conductive brushes. Otherwise, they can generate static and potentially kill your boards.
Yeah.
And give it a good good scrub over. Don't just, spray on your isopropyl and just leave it to drip dry. Actually get your scrubbing brush in there and, over it. Yep.
Yep. That's a good point. Getting the residue off. It feels like that's the main thing, because like sometimes I'll just like be spreading it around, and then it's just like, oh, I made this worse. Like depends on the type of.
I hate it when you drip it, like you spray your isopropyl on your board, you hold over your bench, and then it like drips off, and all the gunk, all the flux residue comes off, and then it's like a murky kind of crap on your bench. It's like
right. Yeah. Yep.
Oh boy.
Oh well.
Anyway, what do we got left? We got like 5 minutes left. What do we got?
Oh, this is there's a really good video actually I just found today. Someone designing, it's just kind of like soup to nuts, doing a design in KiCad, STM32. It's a NRF24 chip, kind of building into like a little platform. Instead of just like buying a low cost, he basically built his own. And it's good picking out parts. It's good picking out or doing some KiCad stuff. Doing some of the firmware choices and stuff like that. So I really just liked it for kind of doing everything together. So that's a good one.
Yep. Oh, hang on. I've got a really good one. I'll try and find the link. Somebody posted on Twitter. It's an Aussie guy, E-Waste Ben. Have you ever seen him?
Okay.
He scraps boards for gold e-waste, right? Because there's gold in their boards, right? And seek your fortune and glory, kid, in scrapping PCBs. And so he's an Aussie, I believe. He's down in Victoria somewhere, and he scraps all these boards. So he's got a YouTube channel and an e-waste business. And somebody, somebody on Twitter posted, who was it who did the twisting capacitor thing to get off the surface mount capacitors, right?
Oh God, yeah.
You tweeted it, and then I retweeted it from your tweet or whatever. And so there's a big to do on there. Some people are saying, and I tweeted, no, that's like I tweeted the force. It's as if
it's painful to watch because
it's painful to watch because you twist capacitor. Yeah. I've done it myself many times over the years, and it does.
I mean, getting those. So these are the large aluminum electrolytics, like the big can capacitors, not like the old school, like not the old electrolytics, but these are the silver cans. So if people are visualizing it, someone basically took a pair of they took a pair of wire strippers, used them as pliers, and just twisted the damn thing off. So it's
and just twist it back and forth, and it breaks the legs and leaves the legs, and then you can get the cap. So you've got the cap off, and then you can get in there if you solder it on and just scrape the pad, scrape the lead off the pad.
Right.
So it isn't magic. You still have to clean those pads up.
Right.
So,
but it actually is really hard to get those unless you have a double soldering iron. It's hard, or like soldering iron tweezers. It is actually hard to get those things off.
No, you get in one side, you lift it up, you bend it, and you get to the other side, you lift it up, you heat up one pad, and you bend it. It's not rocket science. You just need to get access. Access is usually the problem. Like other parts are like obscure in the thing or whatever. So, yeah.
Okay.
Boy.
So this started something else you're saying.
Yes, somebody tweeted. I know E-Waste Ben. I've seen his videos before, and somebody said that's not how you remove components. This is how you remove components. I'll get the link. And he uses a pneumatic chisel thing. One of those pneumatic chisels that like goes in and out, and he's like going, and he's like chiseling off all the parts.
Oh, is this like this is like how they do This is like how they do taking out floor tiles or something like that, like a jackhammer, but like in a chisel.
Yes, yeah. Taking out floor, yes, like a jackhammer with a little chisel end on it, and this is how he takes connectors off the boards. It's awesome and horrific and
that's awesome.
Greatly disturbing at the same time. I'm trying to find the video now. It's just, oh man, it's like, it's
oh man. I mean, like, and so what are the parts he actually harvests? Is he harvesting the boards themselves, or is he getting the parts, or?
Not usually. He harvests the connectors and the pins because pins and connectors are usually gold plated. They're usually hard gold plated, right? Especially like your high quality ones, and especially the ones in the 1970s. They were using gold like it was no tomorrow, and they were really 10 micron hard plated.
Right. Well, the parts were so expensive anyways. why not just plate them with gold anyways, right?
Well, yeah, exactly. And back then, like, 10 micron hard coating. Now it's like, like half a bee's dick. Hard gold. If you're lucky, it's they claim it's hard gold, but it's actually it's like
flash, gold
the
flash.
flashiest gold flash you can get, the thinnest gold flash you can get.
You get one insertion cycle, and that's it. That's all you get.
You get one insertion cycle before the gold wears off. Yeah. It's just terrible. Yeah, they just don't make them like they did in the 70s, And anyway, all you really, so he's scrapping all these boards. He's getting like these Cisco router boards worth $100,000 each. It's just, it's just.
The gold is worth that much, or the boards are worth that much?
No, the actual board. I don't know how much the gold's worth, but you might get like $10 worth of gold from each one or something. I don't know, but it's just so he's.
Oh, okay, but they were originally $100,000. You're saying?
Oh yes, the board to buy is $100,000. Yes, and he gets all this stuff for free. Because people are tossing them out, the e-waste. But and he even salvages like tantalum capacitors. Like I don't know how you recycle tantalum.
Interesting.
But geez, I know tantalum's expensive and it's kind of rare, but it's like, geez.
Oh, he's not using the capacitors again. You're saying he's just somehow harvesting the element.
Oh no, he melts these things down to get all the raw materials, melts them down, and it's just unbelievable.
Yeah, true. Yeah, I always wonder about that with e-waste and recycling and stuff like that too. Like, is someone doing that at some other point?
Oh yes, harvest them and they put them in a big fire and they melt it all down and then it releases all the time. I don't know where the toxic fumes go, probably into the atmosphere or whatever. But and little
right.
dribbles of gold come
right,
out.
Exactly.
Little dribbles of other metals come out. So yeah.
Sometimes I think about this, Dave, and I think about the fact that we're I'm not doing anything super high volume, but we are contributing to this, and I kind of have that sketch in my head of like
probably I know. I think of that all the time. We're so wasteful. We were talking about that earlier in the show. We're talking about just buy it from DigiKey, right? Buying all the parts. Yep.
Yeah. Just buy more parts, right? Right.
Man.
Yeah. I mean, it's a drop in the bucket compared to like the broad, like how much stuff's getting made, but like it's still, sometimes when I think about the element of stuff that's being made, it's like stuff that's being manufactured, and there's a lot of stuff that ends
terrible.
up in the bin.
Anyway, I'm gonna find this video.
So we're ending on a happy note today.
I'm gonna find this video. Here we go. I think I found it. No, hang on. I'm getting there. Please. I'll get there by the time we close out the show, surely.
All right. This show brought to you by our patrons, and thank you to all of them. If you didn't know, you can sign up on Patreon today. You get access to our Discord channel, and you get early access to some content. And we haven't done a meetup yet, but we plan to. Actually, Discord just turned on a thing where all the chat rooms now have video too. So if you go into if you go into the audio chat rooms, they all are enabled with video up to 25 people. So we need to plan to do that at some point and have a little video conference meet up with folks. So we'll set that up sometime soon. But if you become a patron today, you support the show and you also get access to the community. So thanks to all our patrons right now, and hope other people will become patrons in the future. This message brought to you by Dave not being able to find you a link.
That was very professional, Chris.
Dave, do you even, come on, man, do you even internet?
Do I even internet, bro? I'm pretty poor at interneting. It's all new to me, all this internet.
That's what I was saying, So while Dave's doing this, I guess I'll talk more about stuff. KiCad has another plugin that's kind of cool. There's an automatic panelization tool called KiKit, maybe KeyKit. That's probably more likely. And so there's a new tool out there that does panelization. It does it just, I don't think it does, I think it's just panelization with break tabs, not with V-score. But this actually was pretty tough to do in, I mean, you can do it manually, and Peter Ezentempsky has some videos about that. That's what I used to learn how to do it. But now there's more plugins and stuff like that because all the other plugins I had seen in the past had not worked. So
excellent.
Pretty cool that there is this new thing there. All right, Dave, check in, or should I mention another thing?
I got it. I got it.
More stuff on the list. Here we go.
I got it. No, you'll love this. You'll love this. You gotta watch it. Here you go. Be prepared to be horrified.
Okay. Another thing I will mention is if you're an Eagle user, there's also a link on the subreddit. Lamore from Adafruit, Lady Ada, we did a stream as well. We'll link that in. So she did it in Eagle. She showed how she panelizes her boards too. So that's another good one when you want to see like a more manual process. I think Eagle has plugins too, but it is good to see how to do it.
Videos,
and I think
you've
probably
got like a million views.
Panelization videos. You've definitely done panelization videos, right? Yeah. No, like a million views, whatever. Still we do. Just like a million views, whatever. Okay, so I'm watching a video that Dave sent me now. Removing IC chips. Holy crap.
Keep on going. He does everything. Cool. He does the entire board. He's doing it on carpet. Okay. He's doing it on carpet.
All right, I'll watch it more later. Come on. Yeah.
As in on...
Yeah, that carpet. Oh my God. You must have like an industrial vacuum cleaner or something. Huh?
It's just horrifying to watch. Yet somehow satisfying.
Yeah, this is great. We'll definitely have this link here. No, that's great. That's fantastic. Yeah.
I'm watching. I can't stop.
That's actually a great way to take off components too. I mean, like taking off connectors sucks, right? It's better just to knock the plastic part off, go and then desolder all the pins, and then
with your pneumatic.
This is a pretty destructive process.
You're gonna reuse your board.
Yeah.
Oh, it's just I just can't.
Yeah.
You just cannot. I
don't think so either.
You have to watch it. You cannot look away. It is just.
Yeah. Well, these other videos, like 10 most valuable CPUs for gold recovery. Yeah. This is a very specific channel. This is like even more than I expected. If you want to get gold out of e-waste, okay, cool.
That's what he does. He scraps all these components and e-waste, and he gets the gold out of. It's it's a lot. It's a hard, messy business for not much return.
Yeah.
Anyway, right. It's a business. It's works for him.
Do you think he looks at like Bitcoin miners? He's like, you think you're getting riches out of mining? Yeah, come on.
Right. Yeah, it's a hard, messy business. Yeah. So so is this. I mean, there is not much gold. There's like even in a high end board, there might be $10 worth of gold, and the amount of effort you've got to go to extract that, huge furnace to extract all the gold from, melt it away from all the plastic components and everything else. It's just incredible amount of work for very little. But I guess it'd be satisfying in the end. You end up with this little lump of gold, right? So but anyway, brilliant.
So. Yeah.
Well, that's it. That's all we have for this week. We'll link that in. Check it out. It'll change your life.
Definitely. All right, man. Talk to you next week.
Catch you next time.